Okay, so we're going to be looking at the first derivative test to determine if this function f of x has any relative extrema. First thing we're going to look at is not the derivative, but actually the function itself. We need to know if it has any discontinuities. So what we want to find out is f of x undefined. And in order to know that, we're going to look at the denominator. It's pretty clear from the denominator that at x equals 2, the denominator becomes 0, meaning we have ourselves a vertical asymptote. So when we do our analysis, we'll include this as a breakup of our intervals. So now, on to the first derivative. I'm going to go ahead and use the quotient rule. Quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. At this point in time, we could attempt to factor. I'm not seeing too much there though, so I'm going to go ahead and multiply out, distribute, combine, and clean up the numerator. So it's a little tedious, but I think we can do this. That's going to be negative 6x plus 4, distributing the negative, negative x squared plus 2x minus 4 over the denominator. Combining like terms, we've got 1x squared minus 4x, those cancel, and x minus 2 quantity squared. It's helpful to factor that numerator out so we can clearly analyze the first derivative. All right, so at this point in time, we already know that 2 is a vertical asymptote. 2 cannot be a critical number because the function itself is not defined at 2. So while 2 is included in our intervals, it is not a critical number. It's an asymptote. So instead, we do have critical values or critical numbers, critical numbers when the derivative is equal to 0. A fraction equals 0 when the numerator is equal to 0. So x minus 4 equals 0 at x equals 0 and 4. Don't forget though, we do have a vertical asymptote at x equals 2. This will determine the intervals that we're going to be working with. The intervals will be from negative infinity to the critical number 0, 0 to 2, 2 to 4, 4 to infinity. But let's recall, and I'd like to write this right in, 2 is not an extrema. It is just an asymptote. So we are now going to pick test values from these intervals and test them in the first derivative. Hence the name, first derivative test. All right, so our test value, we can pick anything from here. Negative 10 will do, 1 is in this interval, 3 is in this interval, 57 is in this interval. Filling them into the first derivative. I am going to be looking at the factored version of the first derivative. The denominator is squared. Denominator is always positive, so I don't have to worry about that. I'm really just going to be testing the numerator. If I take negative 10 and fill it in, this is negative 10, negative 14 over a positive denominator. Negative times a negative over a positive, first derivative is positive. Filling in a 1. Filling in 1, I have 1, it's positive, negative 3, and this is positive, so this is a negative. Filling in 3. 3, a negative 1, and a positive value. Positive, negative, positive. Negative again. 57, positive, positive, positive. So the first derivative test says now that we can conclude about f. These were the signs of the derivative. The f function will be increasing, decreasing, decreasing, increasing. Now, even if these did change from decreasing to increasing or increasing to decreasing, that's not an extrema, just an asymptote. However, we do have extrema for f. Increasing followed by decreasing makes x equals 0 the location of a relative max. F has a relative max at the value of 0. Over here, decreasing followed by increasing. Decreasing followed by increasing, x equals 4 will be the location, relative min. Now, 0 is not the maximum value. It is the x-coordinate of the maximum value. If you plug that back into the original function, the maximum value is actually a value of 2. Here, our relative minimum is not a value of 4. X is just the location of it. If you fill 4 back into the function, we get a y-coordinate of 6. 6 is the relative minimum, and -2 is the relative maximum.